For a study plan, so we are just starting study plan. What you need to do to study, you need to go to the presentation slides, which you have in PDF. Print it, no problem. I give you to print it. And then if you don't want to print, just in your laptop, you can study also. And then you, after you finish study and listening the video, you can listen the video and take notes. Yeah, you print it while listening the video, you can take notes in the slides. And just after you finish video once and twice, you are okay, understand everything within the video, and you go and answer the question until you finish all the chapters. Then you are ready. You are ready for the exam. You maybe you need just some simulation exam. You can have it from any resources, so many resources in the market. If you already studied everything, then you can just have some simulation exams to be sure that you are 100% ready for your examination. Very simple. You have resources here also, like books and so on, flashcards I put for you. I will put for you where you can answer, review this I will put for you today. It will help you also review all the content by question and answer. This is just a gift from me, okay? Because we are giving the course only, but this is where you can have the question and what is the answer. This is the question, for example. I will explain to you. Here's the question. What are the minimum program requirements? For example, the one we take in LEED process. Okay? Okay. 16 questions here means the number of questions in this part LEED process. So it doesn't matter. Where is the answer of this one? We call it flashcard. The answer of one in the second page, you'll find it here. Number one here to the right. These are the minimum program requirements. 1, 2, 3. Okay. Why one here start from the right and the question here start from the left? Because it's a flashcard. You can print it double face. When you just enter double face printing, the question, the answer, this answer will come in the back of this question. You got it? No. Okay. Very simple. Print this double face. And front and back of the page, not only single page. You will find the question, every question have in its back the answer. This will find in the back the answer. Then you can cut it as a flashcard like this way, flashcard, rectangles, and you can study all the LEED GA course, 400 questions and answers here. You can study all the LEED GA course by question and answer. But this is not the exam. The exam come multiple choices. Are you with me? So you need to have some external source of examination before your exam, and this is not covered under your course, either from LEEDtricks, my website, or any other resources. I'm not recommending any specific resource, okay? So this is the flashcard. I will put it for you today. This is my gift for you today. It will be very nice. Other than this, I already put all these resources. I put already the reference guide for LEED BD plus C version 4. I put the candidate handbook. Just read it, because maybe you have many questions about the examination, the credential maintenance. Okay. That's all. This is the most important. USGBC trademark and policy. This one I put for you already. You read it, please, in the file resources in the Google link. Okay, and the flashcard, I will put it for you today. So you have now 100% complete study resources for the course, including exam information, books. Books not recommended to read because my slides are complete, but if you want to read it as additional information. Don't start to compare. Here is a slide, this word, in there another word, there is additional in the book, there is not in the slide, don't make like this. Slides is more than enough. Read the book as additional. Whatever info you can get from the book, it's only 100 page. This pocket guide, only 100 page. And you will find in it some additional info, but it doesn't come in the exam. Take it as information for yourself. Okay?
دكتور.
This one is more 200. You will find this book is LEED GA. This book also LEED GA. This 200 page. You will find information in this book. Speak about some topics, information about this book. Same topics, but in different way. That's why I told you the LEED GA is general course. So we need to stuck to or be aligned with the exam content. This is the judge. This is the exam content. We need to align with it. That's why my slide is the exam content, my slides. But additional information, go to the book and read. You will have many nice information, many good information as a background support to you. Take it, okay? All right. Let me now go to the, I read, لا, of course it will come from the book. The book contains the content, the exam content, plus some additional content. But it's not too much. The additional content is good for you. If you read the book, it's good for you. So read it, why not? But some people hate books, don't like books. So, okay, it's my slides, exam simulations, exams, flashcards here, this one will be enough. One more thing, guys. When you answer exam simulation, hopefully in the when after 3 weeks we will finish, then you will start to self-study. Don't worry when you don't know one question, because the simulations or the exams has been done to learn from it. So you will learn from your mistakes. Most 90% of engineers take 50%, 60, or fail the first 2 exams. But after the third exam, they will improve because they answer again the same exam. So they will improve to 70, 80, 90, and so on, second or third time. That is normal. It's not something bad to fail the exam first time because you don't know how the strategies of the exam. But after you answer and you see your answers and so on, you will you will know how to answer, how the question come. And I give you some sample questions already that with you every in tasks. The 400 questions, Engineer Ali, these are flashcard, meaning what? It reviews the the course content by question and answer. So it's good for recall question. You remember everything in this by question and answer, like you study the book from A to Z. Okay, but as I said, it's a statement question. It will examine your recall to how to remember the study and so on. But the exam questions itself, it have some other tricks and it come multiple choices. So you need to be sure to answer many questions, as many questions. 5, 6 exams are enough. Okay. Okay. So let's now go to water. Okay. Okay. There are also some social media I have, and I always make discussions and webinars. It's free. So you follow this link I will write in the chat box. This is also free for you guys. Yani it's not for some agreement with the company, but whoever want to attend is welcome. Okay, it's not company funded. It's free from my side. Link tr.ee / LEEDtricks. You go there, you will find links of all social media, especially YouTube, and a group in WhatsApp name LEED Media Group. In case you are interested, you are welcome to join for free. YouTube have many good videos and webinars, and we always guest some people like doctors and speak in some specific areas of sustainability and so on. Last week we have Dr. Ibrahim Tawfiq, and he will speak about the life cycle analysis or life cycle assessment. Okay, so this is in the chat box. You can see it. Just when you click it, you will see all the links. Just make membership in all. Okay. Now let's start our today's session. It's very nice and interesting one. Yes, good. So if there is any late or delay in the screen, please let me know. Uh, I'm in case any issue, so I can just so you can enjoy and see the explanation without any interruption. Now, water efficiency, كفاءة المياه in Arabic. Okay. Water efficiency in this course, where we use water, we use it outdoor or indoor, or we use it in industrial use. But also LEED divided into this section, outdoor and indoor. Okay. And we'll take every one of these in details. But the most important here is these two slides. We need to understand the basic concepts of water efficiency. What is the significance? Number one, we need to protect water resources. And why we need to reduce water or we do water efficiency? Why? Protect the natural water resources. Why? Because we have scars in natural water resources. We say the second war or the coming wars will have a big percentage of war about the water resources. So we need also to reduce the demand on municipal water supply. If my voice not clear, let me know also. If it's loud or low and so on, let me know. Give me a hint in the chat box. Reduce demand. Municipal water supply is the water coming to your faucet in your homes and offices. In your homes and offices. We call it municipal because supplied by municipality, but the source from the start is from natural water resources as well. Okay. Reduce the load on sewage. Don't think that if you use much water, the problem only in water resources problem, but also in the sewage treatment. Water always treated before it go to infiltration or another use. So we need to reduce the load in sewage treatment because sewage treatment plant, where we do recycling for the water, is highly consuming or high consumer of energy, consuming energy. So the more water we treat, the more energy we use. So the more carbon emissions. So it's a cycle. So even we are speaking here about water, but we cannot say it's not related also to energy. It's a problem with water, with energy, as you can see. Water desalination, for example, here in Saudi Arabia, it takes a lot of energy to treat the water. Okay? Okay, good. Reduce load in sewage, and finally, reduce energy usage of buildings by reducing load in water heating and pumping systems. When you reduce water you are using, you know that the water to come to your home or to your office, it need to be pumped it to the higher level floors. So pumping consume energy. In cold weather, it will be heated, okay, or cooled. All this use energy. That's why we need to reduce water. Types of water. This is always very interesting topic. because always engineers connect this to their studies and their work. How the concept in our work we call wastewater. In here in LEED, they have some different definitions and so on, but they are all the same concept. So let's say wastewater, as we can see here, wastewater. Second, just let me. Yeah, here the wastewater in LEED is a gray water and black water. Gray water and black water. Okay. Wastewater is water coming after usage. After you use water, it can come, but there are different types of uses. There are uses like from toilets, urinals, kitchen sink, and this we call it black because it need more treatment, extensive treatment. Of course, toilet and urinal, it's not like bathtub and shower and laundry, okay, or faucets where you wash your hand. Black water take more treatment, so they classify it into black and gray. Hopefully, engineers will not mix the water coming from toilets with the water coming from different uses. Even in toilet itself, only toilets and urinals. This should be a pipe different than this pipe. But actually, even though the buildings, they will segregate at the building level, and then when it comes, before it come to tie point outside, they will mix it again in the manhole. So we did nothing. As you can see, we did nothing. At the end, we mix it again. So better if we are designing landscape or master plan project, we design all the whole system. We need to consider this, that water or wastewater coming from toilets and urinals are different treated than the other water. So we need to make different drainage and sewage for this. Okay, gray and black. Why here in the black we put kitchen sink? It's not toilet and urinals because the suspended solid is very high. Especially in USA, they consider the water from the kitchen sink is black. Why? Because solid, organic solid from food and so on. So they grind it before release. So there is some grinder under the wash basin or the kitchen sink, and it will go. So a lot of suspended solid. Depend on the code, it can be kitchen sink, it can be black or gray. We can move it here. This is the exception which come in the exams. But how you will see, how you will know in the exam? If the exam does not tell you this is gray, so it's a black. It's like here, it's black. So the default case is black. But if the exam tell you the code say it's gray, okay, so then it's gray. But the default when he asks you, the kitchen sink is a black water. Agree? Agree? Question will come in this. Kitchen sink and dishwasher. Why additional common dishwasher? The same like kitchen sink. Here, I put it here. They are neither black or gray, depends on the plumbing code and regulation followed by the project. But I'm telling you, the default is kitchen sink and dishwasher are black. Just to answer the exam questions. Now we'll move to the next, outdoor water use reduction. And this is the first topic today for our study. The previous was introduction to how to understand the different types of water. Outdoor water use, meaning water use for landscape. Water use for landscape. So water consumption of a landscape depends on many factors. So we will study these factors and see how we can reduce in each factor. Here we can reduce the water consumption for landscape. Factor number one, species factor. The types of plant, he mean. To be simple, species means the plants. We have something alive that are the plants, and non-alive that are the hardscape and the soil and so on. So the species factor, which is the plants. We have the native use recommendation, use native and adaptive plants. Why use native and adaptive? And what is the definition of native and adaptive? This now your homework. How to define the native plants, how to define the adaptive plants. Anyone here landscape engineer can define the native and adaptive plant? Or by writing, no problem. Simply the native plants. I think nobody speak because I didn't hear anyone. Uh, the native plants are the plants that are native. We say native speaker. So this plant, it was in Saudi Arabia. So since thousands of years, we come and we find this plant in Saudi Arabia. So it's a native plant. What is the advantage of native? It can resist the extreme heat condition or cold condition, depending on the location. It used lead fertilizer. Like we see the plants in the desert, they grow naturally and normally without even water, like like few amount of water or minimal amount of water, it will grow. These are native. It used lead fertilizer, less fertilizer. It resists insects and disease more. Okay, so native and adaptive. What about adaptive? We know native now. What about adaptive? Adaptive, they can export, we can import from other countries, but other countries' conditions are similar to us. So when these plants come to our country, even they are not native, they are not existing, but they can live and they can grow naturally and normally without using excess water and treatment and fertilizer and so on. Okay, so using native plant is a way to reduce water. Invasive plants like weeds, الحشائش, weeds. Turf grass, I told you before in the previous chapter. Turf grass in LEED is not recommended. Unless it's for football playground, we have to. Okay? This is only exception. Unless it's a playground for school, we have to do. Okay? But anything, any use of turf grass is not recommended. Turf grass is what? Like in the playground of the football. Okay? Consider their escape. Oh, new info. New info. We know I'm landscape engineer. I know only landscape and hardscape. What is their escape? Their escaping is using kind of plant or type of plant that use minimal or no water. When minimal, when no. Minimal when the plant is still in growing stage, first 2 years. After it grow, even you can forget about it. It will just in the seasonal water, it will live or also still using minimal water. So their escaping is kind of plant that will use the minimal water. This all under what? Species fact. We finish it? Yes. LEED will measure this? Yes. Will give you points upon this? Yes. What are the details? How we take the point? How to document this? This is in LEED AP. Okay, so hopefully of you will select 10, 20 people who are interested in LEED AP and we will give the LEED AP complete course. The second factor, we say the plants. The second is the irrigation system or technology. Some technologies consume water like brushing water around that 90% of the water or more than half will go away for the air, for the soil, will not go to the plants, or using some systems that will just go immediately to the plants and they will benefit from 90% of it. So here's the recommendation of LEED to use drip irrigation because efficiency 90%. Remember this. So always use drip irrigation or similar system, whatever the name of it, but the same concept. The same concept. There is irrigation by like they put like a tube near to the plant, and this tube have some holes, and along the plant root it will give water. So this more advanced drip irrigation. It has a name. Irrigation companies will come and give you some money technologies, but you have the concept now. It's a kind of drip. It's not sprinkler. not sprinkler. Why? Sprinkler efficiency 65. Where the pipe here tube spread water around a circle and including the hardscape, the trees, the plants, the water, everything. Even anyone walking, he will come take some part of this water. Uh, Also, sometimes it's raining. The plant does not need any irrigation. The land is still wet. So use moisture sensor. This is advanced. In here, LEED will give you another point. So number one, number two in the irrigation system. So use efficient drip irrigation like drip irrigation. Use sensors. Sensors are moisture and weather. What is the difference? Moisture in the root of the plant or in the soil. We call it also soil sensors or moisture sensors. Weather sensors will be above in the top of landscape or hardscape here to see if there is rain or the weather is humid and so on. So you don't need to make irrigation. We see this picture many times while it's raining and the irrigation system working, some like dramatic view in the landscape. Here, non-potable water for irrigation. But I want you to ask me a question here, to ask me a question. Why I put non-potable water after I use type of irrigation and the plants or species and technology, and then use non-potable water? Someone can answer? I will tell you why. First, you focus in the major systems, the basic systems, then go to advanced systems. How? First, I focus in the plant itself. That makes sense. And second is I focus on the irrigation system itself that I use. That makes sense. And after that, I go to sensors, I go to water itself and use non-potable water. But by logic, tell me, is it really good to use plants that are not native, to make turf grass, to use a sprinkler, and after all this waste, you go and make use non-potable water? You're still wasting. You're wasting the non-potable water because even non-potable water is treated water, right? We used it from after recycle the water and use it. So also don't waste it. So before I use non-potable water, I make sure that I use the proper planting, the sensors, the proper irrigation system like drip irrigation. After that, now it's time to save more for non-potable water for irrigation. So consider using non-potable water for irrigation, and here LEED will give you point. LEED AP will know more details, but here only we need to know that you will get a points for using considering non-potable water. And you need to refer to local codes. Why? Because some codes will not allow for using potable water, non-potable water for irrigation, depend on the country, or it should be treated to some level. Okay, because in some areas before in Dubai, they was using the wastewater for irrigation immediately without treatment. When you walk in the street, you will smell the odors of the wastewater, so it's not good. And also, it can be source of diseases and many, and also children's or anyone walking nearby, or animals or insects and so on. So it needs some treatment before irrigation. We use non-potable water, but it should be treated, refer to the local code. All in all, يعني don't use gray and black water. Okay, gray might be used with some simple treatment. Black water need treatment, and then you can use for irrigation. So at the end, it is non-potable but have treatment. Now, very important part that we need to understand. How we know that we are saving water? What is the standard? How we measure? What is the baseline? We measure against what? If I say I save 30%, based on what? What is my reference? So here we'll answer in this question. First, use EPA WaterSense water budget tool. Is water budget WaterSense? You can, if you are irrigation engineer and you want to make more research, go and write EPA WaterSense water budget tool. If you are not, then just know its name. Okay, because lead for everyone in the project. Some parts you will be interested because it's related to your work. You will do it. Some parts you need to know the name only. So if you are lead coordinator, you will just tell them that use WaterSense water budget tool. Okay, so wherever your location, do the action required. It is a standard. It is not a standard, by the way, but it's a tool that implemented inside it, integrated many standards. So it's a ready tool to measure. Tool ready to measure. I don't need to refer to some specific stuff. It's a tool with a measurement, okay, embedded on it. It's ready. So it's just Excel where you can put some values. It will calculate you are above the standard, you are the blue standard. Good, very good. So what is EPA means? Environmental Protection Agency. Environmental Protection Agency. EPA WaterSense water budget tool. EPA is organization in USA. You can go to their website and download the WaterSense water budget tool. But it's out of our content of the course. This for the practical experience, or if you work as a landscape engineer, please go and do this. I recommend to do that. Baseline. The baseline is the reference line where I measure. I am 30% saving plus above the baseline or below the baseline. Focus here, please. Very important slide. The baseline. And baseline we use in everywhere, even in ASHRAE, in energy, in everything. We use something called baseline. Design case. Design case is what you are doing. What you are doing can be good, more good than baseline, better than baseline. So I save. So I'm consuming less water than baseline, than what standard use, or I consume more than baseline, and this is alarming, yeah, because I need to reduce than the baseline. What about having equal to the baseline? You are also not in a good situation because you need to reduce a minimum 30% than the baseline. You need to reduce below the baseline your consumption of landscape water 30% as a prerequisite, meaning we know prerequisite and credit. It's a mandatory. 30% is your standard, your zero. Starting from 30, you are here just complying with the standard. Is it difficult? Not at all. You apply the practices we mentioned, the strategies like using native plant, adaptive plant, and irrigation system, and non-potable water. All these 3 steps, you apply it, you achieve good score in WaterSense water budget tool. Based on the baseline implemented on it, based on the design case, what you are doing in your design. We see in designs, you are architects, so we'll see the landscape engineer also putting the types of plant within the design documents, like this plant is 1, 2, 3, and they make planting schedule and implement within the design. Now planting schedule have another dimension, which is sustainability dimension and LEED requirements. Any question here? I don't want to go here before any question from you. If it's clear to you, so it will be clear also to the engineers who are listening the recorded material. Okay. So assuming no questions, because I did not hear anything, it's okay. Okay, thank you, engineer. Baseline and design case water consumption. Okay. So we already have it, explained it here. It's just continuation of the topic. It's a good practice also to use in addition to the previous what we discussed about the strategies to reduce water in the landscape, to use meters, make routine maintenance, use mulching. You know mulch? You remember in sustainable site when you put mulch around the plant? Now another benefit of mulch is keeping or holding the moisture for long duration. Like we see in our suburban areas in the country, we see the trees, we put around the trees so dust, نشارة الخشب or organic materials. Okay, we need to maintain optimum lawn height, meaning the lawn height or the turf grass, if we have, we need to always to cut it to the proper height, because the longer, the more water consumed. I think you find this chapter is interesting. Yes, it is interesting one because related to our work. We finished now the first part, which is outdoor water use, landscape, with its standard requirement, strategies, intent. Now we'll move to indoor. Before I move to indoor or start indoor, remember very well that indoor is different than outdoor. The standard used indoor is not the standard used outdoor. Okay? So this is the first thing to remember that make you confused in the exam. Indoor water use reduction. To reduce indoor water consumption. This is the intent. Where we use water indoor? In the wet areas. يعني 4 words only. In the wet areas. 4 words. That's enough for me. Yes. And also where in appliances. What were areas? Plumbing fixtures. Faucets, showers, okay, toilets, urinals, okay, all this. Appliances like what? Washing machines, dishwasher, ice machines, food steamer. Okay. So here where we use. So what we need to apply? We need to apply strategies in here and here to reduce water. So let's analyze. Plumbing fixtures and showers and water and urinals and wash basin and kitchen sink. What to use? What to do? Here is the action. Choose water efficient plumbing fixtures with flow rate lesser than the standard. What does it mean? Flow rates less than the standard. And what is the standard? When we answer these questions, we finish. Appliance, use Energy Star or equivalent. What is Energy Star? What are the appliances? Are there any specific measures? When we finish this, we finish. Yes, that's what we need to do. For here, this part, plumbing, fixtures like toilet, WC, water closet. You see this type of water closet, which is one only. This is traditional one actually. But there is now in the market, you can find here dual flush with 2 buttons here. Okay, this is the first thing, and it's more saving. I find it even more practical and even now cheaper. You imagine the traditional one here is more expensive in some cases than the 2 dual button. Why? Because the European Union start to put some measurements, especially from Europe. You will find the more efficient appliances are more cheaper than the non-efficient appliances. Yeah, you imagine it. We always think that lead will cost us, but no. The trend now in every industry is to sustainable production and so on. But what we need to hear, water closets, they allowed flow rate is 1.6 gallon per flush. What is gallon per flush? When you push this, you will what? You will release 1.6 gallons. Of course, these American units, you cannot transfer it to liters. It will be around 5 liters something. Always in the exam, he give you the numbers in gallon per flush and he will put also a liters or some liters. So you can do this as while you study, transfer from gallons to liters. But myself, I was studying because I need to remember these numbers. You need to remember it. So I always remember the gallons. I remember, and then I remember how to transfer from gallons to liters in case happen he bring for you liters only. But I'm telling you, he will always bring for you gallons because these American systems use always these types of units. So the as per the standard, the maximum allowable rate as per the standard 1.6. But there is a very important note here. 1.6 will make you only achieve the standard. But is there a prerequisite or mandatory requirement to make it less than the standard? Yes. Yes. There is a mandatory requirement that you need to be less than the standard 20%. This number one. Number two, you don't need to comply for everyone, meaning maybe water closet is not less 20%. Yes, but overall water consuming plumbing fixture within the building, it should give me at minimum 20% saving. So it's not the end of the world while you are working calculations that one appliance you purchase or your procurement purchase and it's higher in rate. You say, oh, I lost my lead point. No, no, not like that. Or need certificate because it's separate. No, no. It's a budget. Budget means overall should not exceed 20% or should be 20% less than the standard. But to be more careful, I tell you one by one, 1.6. So if you use high efficient toilet, these are efficient choices, that is now available in the market with 1.28 gallon per flush, divide this by this, it will give you around 20%. It will give you 0.8 something, so it means 20% safe. The standard use is what? Bard also, the last question. AP Act 1992. AP Act here, not Environmental Protection Agency, no. Energy Policy Act 1992. It's act in USA. Now they are using 2005. Doesn't matter, but remember Energy Policy Act. It come to you in the exam 1992. It come 2005, no problem, because it's updated in 2005. Okay, so it doesn't matter 1992 or 2005, but it's not 2000 or 2001. No. Okay. Energy Policy Act, this is standard. So the standard use is 1.6. So the maximum allowed as per the standard is 1.6. If you use 1.28, you are less than the standard by 20%. If you are more or less, is more good. For the urinal, the standard is also EP Act 1992, 1 gallon per flush. But if you use 1 gallon per flush, you are still at zero. The prerequisite is 20% less. So you can find in the market urinals that use only 0.5 gallon per flush. What means gallon per flush? Again, when I press this button, it will flush half gallon. Here, 50% saving. Great. You can use 100% saving, which is waterless urinals. We see it in the malls, everywhere, even here in Saudi Arabia, in many malls. I see it in Jeddah, in Red Sea Mall, and in Riyadh also you have for sure. You can use also non-potable water for flushing, and this another way, intelligent or smart way to use. And if you use non-potable water, they will not calculate it. It's like you are using no water. Okay. For the shower. For the shower use, the standard flow rate is 2.5 gallon per minute. Will tell me, engineer, why are confused? Why now gallon per minute before it's a gallon per flush? Yes, because when you clean the toilet, you just push once. It will release all the water once in just few seconds, 1 second. But when you take shower, you take it for 20 minutes and the flow is continuous. So to calculate it, they calculate how many gallons every minute released from this shower. So become gallon per minute. The same for faucet. Faucet. How many gallons per minute when I open the faucet? The standard, as per the standard Energy Policy Act 1992 or 2005, the standard rate is 2.5 gallon per minute. So every 1 minute standard rate is 2.5 gallon. But actually, there are many efficient choices like using low flow showers and available in the market that use 1.8 gallon per minute or less. You can check in the market. Here, a question will come. Hello, procurement engineers. Do you need to know about lead or no? Hello, procurement engineers. Do you need to know about lead or no? That's why I always say, if you check social media and so on, lead for all engineers, lead for all engineers, even for project manager, for construction managers. Sustainable site, we need how we see how many practices we do on site, on sustainable site, location, site selection, owner, huh? Um, kitchen and the private faucets, the standard rate is this for kitchen, like what you see like this in the kitchen. This is the standard, and this is the AP Act, the standard, and here you need to use less than the standard, like 1.5. I'll tell you it's like good news or bad news. You need to remember all the numbers I mentioned here. This because in the exams you will come, especially the one you must remember, the standard flow rate as per Energy Policy Act 1992. This one. This is will be easy because you at least 20% less at minimum, because you can find many numbers less than this number, but the standard number is fixed, so you need to remember the standard number. In the exams they will come. Public or non-residential, what is the difference between private and public? This is private and kitchen 2.2. Public in LEED have some calculation in LEED AP will take, even if they are the same standard, but in LEED for BD plus C, when we take, they have some schedules for calculation that in public use, they are give some more flexibility in public. Why? Because in public, there are a lot of use of these faucets, so the numbers will be different. But in here, LGA, they are the same, okay? But you need to know, just to know, there is public and there is private and kitchen, public and non-residential. From where AP Act come, as I told you, AP Act 1992, then they updated it 2005, and they come from Uniform Plumbing Code and International Plumbing Code. Mechanical engineer, hello, they know this very well, if there is mechanical engineer here. So what we need to know, only these two, but also know that they are, because it is a, what you call, the international plumbing codes, these are codes, but in here this is act. The act is like something I put regulation for building heights. Is it a code? No, but based on some standards, I gather information from the standards and code and say this is a proper height percentage. Street to the building height should be like this because of the sun and so on and the ventilation. So the act, it's like a law. A law. خلاص become a law. So when you take building permit in USA, they always comply with EP Act 2005 or 1992. You got it? WaterSense. Went to Carrefour or any or Panda or any grocery here will have appliances or extra or whatever. You will find in the washing machines badge like Energy Star. We are very familiar with this badge. But WaterSense is the same like Energy Star, but it's about meeting EPA criteria, not Energy Star criteria. Energy Star for energy. EPA criteria for WaterSense is US EPA certification, which certify performance criteria of water efficient product. So it's a like Energy Star, but for water. Remember this badge. Okay? You will see it somewhere. Is this badge mandatory? Yes, it's not 100%, but even you don't have this WaterSense badge, at least you need to prove that you are complying with the LEED requirement, which is the below the EPA standard that we studied before. Here we come to Energy Star. So Energy Star is certification for products. I telling you also, LEED is not certifying products; it certifies a building. But some other certification certifying products and materials like EPA, our Energy Star, okay, like LCA for materials, like EPD, will take environmental product declaration, like HPD, health product declaration, come with the product. Here, Energy Star. So also the appliances should be Energy Star, and you will report this in LEED AP as Energy Star appliances. The baseline here is also Energy Policy Act 1992. It's different from the outdoor. The outdoor it was different. The outdoor, you remember, it was what? It was outdoor water use reduction. It was WaterSense water budget tool. But here we use EPA 1992. Okay. So the baseline here is 20%. We need to be 20% less than the EPA 1992. We need to be 20% less than EPA 1992. In outdoor, do you remember what is the baseline? It was 30% below the standard. So it was different, of course. Now we'll move to very, very important part of the water, which is calculation. It can come you in the exam, simple one, which is FTE. FTE, what does it mean, FTE? Occupants in the buildings are residents or transit. Transit, they come and go, like in the airports, like in the malls, shopping malls. Okay. From here, I'll ask you one question. I am calculating the water consumption based on the standard used for a mall. It's very difficult. Why? Because I have thousands of people come and go and transit in the airport. Very difficult. But okay, make it more simple. In the office, I have employees that only stay for 8 hours. Okay, so when I calculate based on the number of employees, I have 100 employees. And I calculate also in another building, have 100 employees that are working for 2 hours only. Some types of place you work outdoor, but indoor only 2 hours. Oh, I think there is an issue because the people who stay for 8 hours, they will not consume the same water amount that used by the people who are using for 2 hours or visiting mall, stay for 1 hour and go. From here, they make standardization. FTE means full-time equivalent. They make the standard rate based on 8 hours. So I am always multiplying the number of occupants by the number of hours they stay and divided it. So if I multiply the number of residents, like let's say 100, by the number of hours they stay, 100. Focus, we finish. 100 people. Okay. Everyone stay 8 hours. 8 hours. So what is the total number of hours they stay? 800 hours. Right? Okay. 800 hours divided to 8 again. It will give you what? 100. So I have 100 full-time equivalent. Make it more simple. 100 people. Everyone stay 1 hour. So how many total hours they stay? 100 hours. Okay. So the total hours they stay, the 100 people is 100 hours. Okay, but I want to calculate based on full-time equivalent. Divide this to 8. 100 divided to 8 is what? 12 point something. Let's say we make it 13. 13 hours. So the actual number is not 100 people, it's 13 people based on full-time equivalent. Why? Because they only stay 2 hours. They only stay 1 hour, not 8 hours. So I divide to 8. I divide the total number of people, the total number of hours to 8. So it gives me 13 hours, 13 full-time equivalent. Still not clear? I can explain more. It's okay, we can go. But remember, this calculation will be based on energy, water. It will be very beneficial for you in every calculation in LEED and the others, and in your work also. It's not related to LEED even, but LEED use it full-time equivalent because yes, So what is the full-time equivalent? Sorry. The full-time equivalent, very simple one. Remember what I will say now. Full-time equivalent, remember what I will say now. Occupancy based on 8 hours. Okay, 8 hours. So occupancy based on 8 hours. So occupancy hours based on 8 hours. So every eight give me one. So eight in down, and in the top is occupancy. In the top, occupancy, and the eight is down. Occupancy based on 8 hours. How to calculate here occupancy? Very easy. Number of occupants by the number of hours they will stay. So 200. This will give you the FTE. Easy? Yes, now it's easy. If you don't understand it still, you can listen to the recordings. You will 100% sure understand it. Try it by yourself. Of course, maintenance and regular maintenance will participate. So we need to put operation and maintenance of manuals and include the requirement for water systems, how to maintain it, to avoid leakage and so on. Now we'll move to the next credits, which is metering. We finish indoor, outdoor, indoor, now water metering, and then finish. Water metering is very easy, but the only important that you need to memorize these two simple words lines that you will just pass it. It's just a wording. No, no, no. To support water management, I identify opportunities for additional savings. Four words. Identify opportunities for additional savings. Why? How I do saving first, in the first instance? I do saving in outdoor, in indoor, appliances, all what I explained. Now, for metering, what meterings will add to me? What meters will add to me? Here, identify opportunities for additional savings. I'm asking you, what meters will give to me? It will give you identify opportunities. Meters will give me more savings. They are measures. They are just measuring. Yes, because based on your measure, you will take some decisions. There is a leakage. My last bill, water bill, it was 500. Now I have 2,000. For sure, there is a leakage or an issue within the system. I will go and fix it. Yeah, so it will help you identify leakage or issues or additional consumption and monitor and take decision for the water. That's why we say it's important. And you can identify it in two ways. One is mandatory, is a prerequisite. One is credit. Of course, the mandatory is the meter for the government that they will use the reading for the whole building or whole apartment. Depend on the ownership. Okay? We call it building level. This is a prerequisite. But if you want to meter the correct way, you meter by system. We call it sub-metering. How I meter by system? I meter the water use for landscape 1 meter. For indoor, 1 meter. For wet areas, for example, 1 meter. For roof cooling tower, if we have that use water cooled, 1 meter. So 3 meter or 4. If the building have different zones, maybe for every zone, 1 meter. But I'm not saying that an manager which have toilet in his room will put for him meter. So I'll put for every faucet 1 meter. No, the major systems, you always put meters based in the importance, how this system is expensive, or how much the amount of water used in this system. So they have allowance. You don't need to meter every faucet, but you meter some systems, indoor, outdoor, and indoor, not every faucet. For example, I have group of toilets and kitchen within an area, and one toilet very far, stand alone, nearby some office or something. No need. So there is allowance of 20% or more to neglect or to exclude from your metering. But at least you meter 80% of your systems. Okay. Building level is a prerequisite, and the sub-meters is metering by system. Okay. 1 second. One more thing. When you meter, you need to document. and commit to share the data with United States Green Building Council for 5 years. Metering and submetering, okay? You need to share. How you share and what to do, you share it through third-party system, we call it Energy Star system online, but it is not part of LEED during operation and maintenance of the building, especially if you are going for LEED O+M certification. Now we'll move to the last part of our water, and then we'll leave you for one break, which is cooling towers. Cooling towers, you see it like that or bigger in the roof. It use water because it's open system. Here is open, not closed. Why? Because it's hot water. You cannot make it closed system. Okay. In cooling tower, we need to conserve water used for cooling tower. Make up. What is make up water? Because of evaporation here, always water are lost. So we always add additional water to compensate. We call it compensate. So we call it what? Make up water. Compensate the loss. So that's why they call it make up water. So to reduce evaporation, you do some technologies like screen here or reflectors to let the water drip again in the system and so on. But still also it happened. So we have to try to reduce make up water. Also, some systems, even they are not using the cooling tower, the hot water, they will just release it to the water streams or whatever. So no one through cooling equipment. What is one through cooling equipment? Which use water and then go to drainage. Use water, what that? That use a lot of water for heating or cooling system. If you are one through, you will not recirculate. So of course, cooling tower is better, but we need to recirculate the water or consider some considerations also within the cooling towers. Consider use non-potable water for cooling towers. Non-potable water, but it should be treated because this is a equipment. If you use water that is not clean to the standard, it will impact this machine. After that, it will rust and accumulate some salt and so on and cause corrosion. Okay. Maintain higher cycles of concentration, meaning the more water will come and go or recycle or go through the cycle from the building to here to be cooled, and then from here to the building and so on. This is a function of cooling tower. It takes the hot water from the system and then it will be cooled down and then again push the cold water to the system. Sometimes they use the chillers or different systems, but here for the cooling tower system. A sub-meter and track is also very important. Okay? This is the cooling tower. We consider cooling is industrial. Okay? Why industrial? Because water or process water. Process water, this is the last part I want to mention here before the summary, is water used for industrial process. Like cutting the marble, this is a process water. Like boilers, this is a process water. Okay? So outdoor water use reduction. We studied. In indoor water use reduction, we speak about indoor water use. Process water such as cooling towers and boilers and chillers that we explain, where the water is in loops, move in loops in boilers or cooling towers. You know, sometimes you consider washing process, like washing machine is a process water. Why? Because it do a process of washing cycles and so on. Even though after some cycles, they will release it. Building level water metering and metering also, this is the last. We said meters is consider opportunities for additional saving. So for here, we finish the chapter water, and after break, we'll go and answer some questions before we start in the next chapter, energy and the atmosphere. Thank you and see you in 12:45. Thank you very much.